So here we have a problem dealing with the binomial expansion. It says the constant term in the expansion of x over a plus a squared over x to the sixth power, where a is an element of the real numbers, is 1,280. So find what a equals. Okay? Now, this is the constant term. On a lot of our binomial expansions, the constant term is which term? Come on, you guys know this. The constant term on a lot of ours, like when we have, say, a 3x minus 5 to the ninth power, what term is going to be just a constant, no x's?
5.
Well, that's one of it. What's the term of the expansion? Like once it's all multiplied out. Come on, guys. We're in big trouble. Okay. The constant term. We're talking about terms, things that are added. So when you expand this, you get something plus something plus something, blah, blah, blah. We're going to have 10 terms because it's the ninth power. Okay? Where's the constant term going to be? The last one, because it's just going to be negative 5 to the ninth power. Okay? That's often where it is. In this case, that's not going to be where it is because both of the terms in our in the binomial have x's involved.
Which is tricky.
Okay? So, let's think about what term we're going to need in order for our x's to cancel out and for us to get a constant. Alright? So, if you think about this, x over a is going to have to be to a power, and a squared over x is going to have to be to a power, and we need our x's to cancel out. So the question is, what power is here? And we're also going to have a combination, 6 choose something. Those aren't zeros.
We'll have to where, well, the a squared has to be smaller because it's going to come back with the squared, right? So it could be like 6 and 3, or no?
Well, it couldn't be 6 and 3. Why? What do we know about the exponents here in our binomial expansion? Every term, the exponents have to
Subtract by 1. Isn't it like 6 and 5?
We have to add up to whatever whatever the 5 is. Oh, 6.
They have to add up to 6, right? And think about it. Once we multiply it, we want x to a power on top. X to that power is going to be on the bottom, and we want them to cancel out. So what do the powers have to be for them to cancel out completely?
3s.
They've got to be 3s.
The same.
They got to be the same because we're going to have x cubed over a cubed and times a to the 6th over x cubed.
Oh, then they automatically.
Yeah.
And they'll cancel out. So now we know this is going to be a 6 choose 3.
That's a great critical thinking question.
Alright, so now it's just a matter of solving the equation. We're told this thing equals 1280.
So you just do 6 choose 3
6 over 8. 3.
times a to a third.
Yeah, good. That's going to be a to the third. So 6 choose 3. That's 6 factorial over 3 factorial, 3 factorial times a cubed. Alright, so you're going to have to do some arithmetic by hand. Alright, this is, I don't know if this is a non-calc or a calculator problem. Anyways, but it wouldn't be terrible because 6 factorial, 6 times 5 times 4 times 3 factorial, that cancels out one of these.
What about 2?
What is 3 factorial?
6.
6, so that cancels out this, so I just have 20 a cubed equals 1280. Okay?
Doesn't even be puberty 1280.
Well, no, we would divide by 20 first. If we divide by 20, that would take care of the 0, and then that would be, divided by 2 would be 64. And you might recognize that one. The cube root of 64 is 4. Okay? So A has to be 4.
Once we find out what they were actually asking, it's much easier.
Yeah,
Exactly,
I didn't understand what the question was.
And really, with a number of problems on these exams, part of it, one of the hardest parts is just figuring out what in the world they're asking you to do. Okay. Now, you can see on the mark scheme here, okay, finding the right term. Okay, well, evidence of binomial expansion, okay, are you on the right universe here? You get a mark for that, okay? Then, identifying that you need your power to be 3 is another one. And then, writing out that correct term with the combination, the x over a cubed and the a squared over x cubed. Alright, that's worth 2 marks right there. Then, just setting that equal to 1280 is a mark. And then, solving it, working... working to cancel out the x's and get the equation with just an a in it is another mark, and then getting your final answer is a mark. Okay? So, it's a challenging one, but doable. Okay? Just really have to think. And it, again, we like these ones that really force us to think about a situation kind of from a different perspective. Okay. All right. Let's look at this vector one. How many marks is this? One, 2, 3, 4, 5, 6. Oh wait, no. 1, 2, 3, 4, 5, and then another one for A. So 6 total. Alright, this one is kind of similar to the one you had on the mock exam. Okay? So let's see what it says. It says the following diagram shows quadrilateral ABCD with AD equivalent to BC. I would go ahead and label that. Alright, AD is equivalent to BC. AB is 3, 1. And AC is 4, 4. So I'm going to draw that in here. That's the vector 4, 4. Okay? Now it says find BC. How would I find BC?
You could add, right? Well, you could do BA plus AC.
We could. It's actually easier than that. What were we?
What's quadrilateral? Is it the same as parallel?
Quadrilateral just means 4 sides. Not necessarily a parallelogram. Okay, just 4 sides. What do we know about BC?
Equal to AD.
It's equal to AB. Alright, so BC equals AB, or is equivalent to AB.
No,
So,
it's AD.
oh, sorry, yeah, AD. Wait, did I label? Oh, wait, I labeled, hang on. There we go, AB is 3, 1. Sorry. Alright, so, what did you?
I said that you could do addition.
Okay, yeah, okay. That is not quite as easy as I thought. We do need to use the addition. I was gonna say, okay, if AD is 3-1, then BC would be 3-1. Alright, so that's AB. Alright, to get BC, you were right, we need to do BA plus AC. Now, what's BA?
Wouldn't it just be 1, 3? Or no?
Right idea, wrong execution. We need to change AB to make it backwards, but we don't do that by flipping
So
the.
that'd be a negative.
Yeah, you make it the negative. Alright, so that would be a -3, -1, plus 4, 4. Okay? So we get 1, 3. Okay? Does that make sense? Now it says show that BD is -2, 2. Show that BD is -2, 2. How would we do that? What do you think?
We add AD and
Okay,
We don't have AD, so we couldn't do that.
AD is BC.
AD is the same as BC. Okay, which we just found,
Oh, so
right?
then you could do that. Never mind.
Okay, so AD equals BC, which equals 1, 3. Oh, not a fraction. 1, 3. And then to get BD, we would have to do BA plus AD, right?
So it'd be -3.
BA plus AD to get BD. And that means we have BA again is -3, -1. And AD is 1, 3. So that equals a -2, 2. Okay? Alright, now it says show that BD and CA are perpendicular. And this takes something you gotta remember.
Well, can't you prove if it's a parallelogram?
You would have to show it's a parallelogram, but not every parallelogram has perpendicular diagonals. What kinds of parallelograms have perpendicular diagonals?
They have
Just the-
parallel opposite sides of parallel and equal.
Okay, that's for a parallelogram. But a rhombus is a type of parallelogram where the diagonals are perpendicular. So if you proved that this was a rhombus, then you could say, okay, diagonals have to be perpendicular. There's an easier way though. And that is, if they're perpendicular, remember the term orthogonal? Orthogonal refers to the angle between them being 90 degrees, they're perpendicular, okay? How did we know they're orthogonal?
Do I make
There's an equation in there.
The dot product, yep, the dot product has to equal 0, okay? So BD dot CA equals 0, okay? That goes back to your formula for the angle between vectors. The cosine theta is the dot product over product of the magnitudes. If cosine equals 0, which the dot product equaling 0 would be, the inverse cosine of 0 is 90 degrees. So, that's how you would have to show that one. Okay? So, do the dot product and you're good. Alright, see you guys.
I really did like that question.
Yeah, this is a good one.
I thought that was a really good question. Because it's not that it's hard, but you have to know your stuff.